My name is Juyong Song. I'm working in Samsung Research. Okay, let me start. The Samsung Galaxy S24 series, followed by the Galaxy Z Flip 6 and Fold 6, bring many new AI-based features that enrich the everyday lives of the Samsung users. In this talk, I'm going to discuss wallpaper translation using generative AI, one of the functions of the Galaxy S24 series and Flip 6 and Fold 6. Photo ambient wallpaper with our generative AI engine was a left feature in Galaxy S24 series and is now an official functionality in Flip 6 and Fold 6. For example, send your photo on your lock screen with a photo ambient wallpaper and wait for the sunset. Your lock screen shows a beautiful sunset with a golden glow. As nighttime approaches, the sky on your screen turns dark and objects fade. You will realize night has come through the small window in your hand without going outside. Our journey for this wallpaper translation started at CES 2023, where Samsung introduced the vision for emotionally engaging AI services through generative AI. In 2024, at Samsung Galaxy Unpacked event in Paris, AI-powered Galaxy Z Flip 6 and Fold 6 were introduced with personalized wallpaper, including photo ambient wallpaper. With the photo ambient wallpaper, your lock screen adapts to current time and weather conditions using generative AI technology developed by Samsung Research. We collaborate with Mobile Experience Business, Samsung AI Center Cambridge, and Samsung R&D Institute India Bangalore, SRIB. Thanks to these collaborations, our model runs entirely on the on-device hardware, but it needs a network connection to get the information of time and weather. In this talk, I provide more details of this generative AI model and what we have done to overcome the difficulties. Our model is a text-guided image-to-image translation model. Every image-to-image translation task is challenging because it is required to satisfy two different objectives. One is changing the elements of interest, and the other one is preserving non-target elements. In short, we aim to change the target elements only, while the others are preserved. On the other hand, the text-guided image-to-image tasks are categorized into two tasks. One is object variate, and the other one is object preserving. In the object variate task, the main object is only modified while preserving the background. However, in the object preserving tasks, the main object's identity, structure, and the detailed features should be maintained. At the same time, the background or the style of the source image is modified well following our text instructions. Our wallpaper translation is a letter on object preserving task. Therefore, we need to meet the three different goals. One is object preserving. Second is applying effect well following our text instruction. Lastly, we need to meet the needs and preferences of providers and designers. So I named it emotional engagement. Wallpaper translation is not only an engineering, but also an artistic work. So artistic customization should be considered. I'll briefly review the diffusion model. Diffusion model is a type of image generative model, which is different from variation autoencoder or generative adversarial networks. So every image generative models transform a known random noise distribution to unknown image distribution. What diffusion models learn is the trajectories of the two distributions. Specifically, a diffusion model generates image via a denoising process, which requires several time steps to achieve good output quality. At the same time, there is a limitation of diffusion models that takes time a lot compared to the other generative methods. Lastly, classifier-free guidance is widely used for the conditional image generation. To be specific, the CFG scales control the strength of the condition of the generation. Let us come back to our model. I mentioned that wallpaper translation is an object-preserving, text-guided image-to-image task. So we have to achieve the two goals. The target object is preserved while the other should be changed. Then, due to the changing preserving trade-off relation, we face a dilemma. If we apply effect too much, the object is also changed. Conversely, if we apply effect too little, the background remains unchanged. To resolve this issue, we propose a novel method, SegScale, to preserve main objects in an image. It is a technique that combines segmentation and mask editing. It preserves the identity of the target object while background is modified naturally, seamlessly, using our diffusion model. Common mask editing needs more heavy computations, while our method optimizes the process without additional heavy computations. SegScale is mask editing using external information obtained by the segmentation module. But the number of function evaluations of the denoiser, especially UNet, is the heaviest computation and the burden for the on-device generative AI. So one more inference and mixing them for object preservation is not a viable option. Instead, by only modifying classifier-free guidance, finally, we successfully control the object preservation without increasing the number of function evaluations of denoisers. As depicted in the figures, the SegScale method effectively changes the main object area while successfully reflecting the specified conditions in other regions. For snowy conditions, when SegScale is not applied, clauses in the image tend to change it to the winter seasonal ones to follow the context of the images. So it may fit with the weather, but it is not expected. With the SegScale, we can effectively apply less modification to the segmented region, conserving the clauses from the weather changes. For night conditions, the main objects are not expected to be excessively darkened. Diffusion models often tend to darken the entire image regardless of our intention. After applying the SegScale, the main object remains bright. In practice, due to the SegScale preserving the main object's identity, we can apply the time and weather effect strongly to the background. To meet the preferences of providers and designers, or promote emotional engagement, we developed a novel clip-based metric, customized clip score, and applied the texture inversion method. Clip is an image text alignment model. A customized clip score can measure the similarity between an image and the positive prompt, and the dissimilarity between an image and a negative prompt. Lastly, we applied the texture inversion method to assist prompt engineering to follow the designer's instructions. Only prompt engineering is difficult to meet the needs of the designers. Using the texture inversion method, the designers were able to help to develop the model directly by selecting the photos. Customized clip score is developed based on the clip score. Clip is an image-text alignment model, so the model gives the score between the image and the text. When the image and text features are located in a closer space, then the score is higher compared to the other words. Customized clip score measures how well a modified image reflects a positive text and does not reflect a negative text prompt. Customized clip score measures, so two different metrics. And the metric is developed because our preference is different from just matching the words of the time and weather. It also needs some prompt engineering for a good correlation with the qualitative evaluations, which reflects our preference. After some prompt engineering, we got these results. This time, this table shows a Kendall rank correlation of each quantitative metric with the qualitative evaluation results. Finally, we used the customized clip score for filtering our newly trained models. So, correlation is the most largest in the customized clip score. Texture inversion is commonly used for text-to-image tasks, while we use text-guided image-to-image tasks. Texture inversion learns text tokens from images so that we can reuse the learned text tokens for the prompt engineering. Once the token is trained with the text-to-image tasks, we use the learned tokens without further fine-tuning. Prompt engineering is also one of the most important aspects of efficiently improving the quality of the generated images without additional training. Prompt engineering can control the outputs of by modifying the text conditions for the generative models. For example, the questions of ChatGPT is also a prompt. In our case, the prompt is the text instruction for the time and weather. In addition to our prompt engineering, we adopt texture inversion to generate the images following our intention. Two images are slightly different. Without texture inversion prompts, some images are too red. So I think you cannot see very well, but sometimes the images are too red, but with the texture inversion, it becomes more natural and meets the preferences of providers and designers. In this way, designers can involve in the developmental loop for a good quality of the results. Here are some results on our PC version wallpaper model. Our wallpaper translation model supports 8 different outputs, combining 3 time conditions, noon, evening, night, and 3 weather conditions, sunny, rainy, snowy. They cover 12 conditions on mobile phones, including morning. The input image is assumed to be a photo taken on a clear day during daytime. In other words, the original image is set as a sunny noon image. In sunny noon, the original image is displayed. Photo ambient wallpaper was first introduced in Galaxy S24 series as a left feature allowing users a new experience. Since its initial introduction, it has been improved via extensive evaluations and updates, resulting in its official launch as a feature on Galaxy Z Flip 6 and Fold 6. The AI-based animation developed by Samsung MX Business conveys outdoor ambient context seamlessly to the flagship AI phone users, enhancing the overall aesthetic experience. Moreover, it's informative. For example, this left and right clips are records of Galaxy Z Fold 6 for snowy and rainy night conditions, respectively. Here are some pro tips for selecting photos for photo ambient wallpaper. At first, it is good to select a photo on a clear day with the sky. To see the time effect well, a photo with the sky is better. Second, if there exists a main object in the photo, a sufficiently large object is good. It might be ignored by segmentation model if it is too small. Third, consider selecting your own photo. I believe that it will give you another experience. It's your own photo, but it evolves with the changing time. Thank you for your attention.